Hello and welcome to the Django GraphQL Query Fundamentals course. My name is Xander. This tutorial is part of a whole course playlist available for free on YouTube. For deeper learning, the extended course is available for purchase at Udemy. Now you'll find all the resources and links in the video description. And don't forget to subscribe to the channel for weekly promotions, discounts, and Udemy course giveaways. In this short tutorial, I'll walk you through how to create a basic container setup for PostgreSQL and Django. Now, this is a two-step process. In this tutorial, I'll take you through how to create a basic Dockerfile, how to define the services within a Docker Compose file, and go ahead and run and test both containers work together. And then in the next tutorial, we're going to need to, within our Docker container, programmatically create a new Django project and then connect it to our Postgres database. In this course, we're going to run, develop everything from within Docker containers. We will write the actual code locally, but that will ultimately be automatically transferred to the container, and we will then run Django from our Docker container. Right, so you're going to need to create a new project folder for this new project. You'll notice that I am using source control, and I won't be covering source control in this course, so you will find files such as git attributes and git ignore. You can just ignore them if you don't know anything about source control or you're not using source control to manage your code. So just ignore them if you're not too sure what they are. Right, so let's start off then by creating a new folder. Open that folder up in Visual Studio Code, and let's create a new file. So this file is going to be called docker-compose.yaml. So this is a YAML file. Now this Docker Compose file is a YAML file, usually named docker-compose.yaml, like we've done here, is used to define and manage a multi-container Docker application setup. So here we're going to define multiple applications we want to run in separate containers. And we can do that by describing or defining them here in our Docker Compose file. So for each service that we describe within this Docker Compose file, typically we need to provide it a name so that we can identify it when it's created as a container. We need to identify the image which we want to make the container from. We might need to map over ports so that we can actually access the container from our local machine. And if we do have any data requirements, so if we do need to persist data once the container has been removed, then we need to set up any volumes. And then most images will provide the capabilities of us to set and define environment variables so that we can pass those settings into the container. Right, so first of all, as we saw in the preview, when we create a multi-project setup like this in Docker Compose, typically Docker, when we run the containers, all the containers will be under the project name or the stack name. So we can give that stack a name. So let's call this Django GraphQL project. Okay, so now we need to define some services. So what's important here is that you follow the indentation. If you don't indent correctly, then the Docker file will not run, but you will be provided information about that. If you have made any mistakes, Docker will tell you and help you to find those mistakes. But here, everything is on the root level at the moment, and then we indent to define our first service. So this is going to be called a Postgres service, is what I'm going to call it. This is my database service. And first of all, I identify the image that I want to use to create this new container. Remember, these images are going to be pulled down from the Docker Hub service. You can see here for our Postgres database, there are multiple versions depending on maybe which version you want to use. Maybe you want to use a legacy version or the latest version. So here, each version tag refers to a specific release of PostgreSQL. You can also use the latest tag. So there's a latest tag here, but usually it's better to pick a specific version, and that way your setup stays consistent over time and you know exactly what you're working with. When you're choosing a PostgreSQL image or many other images, you might see tags like bookworm, bullseye, alpine. These refer to the base operating system used inside the container. So bookworm and bullseye are versions of Debian. They are stable, full-featured, and widely used. And then also we have Alpine here, which is generally much smaller, minimal Linux distribution designed for lightweight containers. But this can sometimes be harder to work with, especially for beginners, because it lacks some of the common libraries or tools that some of the other distributions have. So generally, if you don't know what tools that you'll need, then just download the whole thing. In this case, maybe 17.4 or 17. But once you have a general idea of what tools that you need to run your Postgres database or what features you want to include, then maybe you can start to select different versions. Right, so we're going to run Postgres 17.4. Don't worry if there is a later version, as of recording, the latest version is 17.4. But of course, that shouldn't be a problem if you are running newer versions. It should work absolutely the same. So let's go for the container name. So I'm going to call this inventory DB because we're going to build an inventory type of database. So I've just called this inventory DB. The container name so I can identify the container when it's running. You can change that, of course, and I'm going to set this to restart always. So if there is any problems with the container and it stops, it's going to try and attempt to restart. Right, so like all containers really, we can pass in environment variables, and we can do that to pass in data into the container so that we can use it to set up databases or perform other tasks, or we can use environment variables for the setup process for the container. Now, in the case of Postgres, we have to, by default, pass in the Postgres user name and the password. If you need more information, you can simply just go over to Docker Hub, zoom in a bit, and you can just read through, and it provides you with the information that you need in terms of what's required in order to get the image started. Okay, so then last of all, we've specified to create a database when we build the container. So this is just going to automatically build a new database called inventory when the container starts. So that's just a convenient way of actually creating a database in preparation for us to populate it with, in this case, Django. Now, remember that containers are isolated environments. We cannot access a container unless we actually open up ports to access the container. So network ports, think of them like doors into the container. In order for us to access the container, we need to open that door, our port, so that we can access the service within it, in this case, Postgres. Now, our Postgres database is actively monitoring port 5432 by default. So if we open up the ports, so what we're doing here is we're mapping port 5432 on our local machine to 5432 in this container. So anytime we send any network traffic to this port, it's going to make its way over to this container. And as Postgres is actively scanning and waiting for traffic on this port, it's going to then intercept that data, and then we can interact and communicate with our Postgres database. And now we can create our second service, our Django container. So notice we start here by first indenting at the same level as the first name of the first service, Django now, and then I define build. So this build context here is going to allow me to specify another file, and in that file I can then customize the setup of the image and then potentially how the container runs initially. We'll take a look at that shortly, but let's first of all finish this off by identifying the container name. In this case, I'm going to call it Django app. Restart always, like before, depends on. Okay, so what we want to try and do is to set up an order in which containers are started. Now, there's no point necessarily starting our Django container unless the database is actually started. So what we're doing here is defining the order in which our containers start. This Django service depends on the Postgres service. So Postgres, that's the name of the service. That's what I'm using here, the name of the service. So if you do change the name of the first service, make sure you've named this appropriately. So here depends on, we'll ensure that our Postgres service runs first, and then we can bring up our Django container. Right, so by default, Django runs on port 8000. So we're going to need to map port 8000 on our machine over to the container so that we can access our Django service within the container. We can also specify commands, which we will do shortly, but let's first of all focus on our image setup. So let's create a new file here. I'm going to call this Dockerfile. So there's no file extension here, just Dockerfile. Right, so this is a Dockerfile which sets up the environment for our Django application. So here what we're doing is we are defining first of all the image that we want to use to build our Docker container, and then we set the working environment. Now this here is Alpine, which is a lightweight version of Alpine Linux, and like I said, we then set the working directory to app. So that's the folder that we're going to be creating our Django project within and setting up everything inside of our container when we build our application. Now what this Dockerfile is doing is we are customizing the base Python image. So we're downloading this Python image, which is an image which includes essentially just a Python runtime so that we can then build a container that has Python so that we can run our Python applications. So what we're doing here is we're downloading this image, we're setting this new work directory called app, and then we're going to install our dependencies required to actually connect to our database. So what we're doing here is we're essentially downloading the image and then we're customizing the image to include other dependencies that we're going to need to actually run our application within this container. Now, because this is a lightweight version of Python, we don't necessarily have all the tools that we need to interact with our Postgres database. So without needing to know any more information, these are all the dependencies that we're going to need to install to successfully connect and work with our Postgres database from within this container. Remember, the Postgres database will be created and running on a separate container, but we need the tools in this container from our Django app to actually be able to interact with it. Now, in addition to that, we are going to copy across a file called requirements.txt, and we're going to install all the dependencies that are needed to run our Django application. So let's create a new file here called requirements.txt, and in here we need to specify all the software that we're going to need to run our Django application. So let me just bring that in. So these are all the dependencies and the current versions I'm going to be using in this course. So by defining the versions here, it just makes sure that we're all working from the same versions of the software. So hopefully we should have the same experience. Now there's a few things missing here, and we will update this a little bit later with the Strawberry GraphQL dependencies, but let's just go with this to begin with. So here we have our Django install. We're going to use the REST framework, so we install that. We're going to need some sort of API documentation. So this is what we're looking at here. DRF Spectacular is going to provide us a nice friendly UI for us to interact with our DRF endpoints. And this here is the database driver for us to be able to connect and work with the database. Think of this like the middleman. Django is going to need this to interact with our Postgres database. This is going to handle the communication between Django and the database. Right, so what we're going to do here is we're going to copy that across to the image. And so what we've done is we specify the file and then we specify dot where we want to copy it to. Now remember, we've set the working directory as /app. So within this image that we pulled down, that's the current directory that we're working in. So we simply copied this file over to that image folder, app, and then we went ahead and we've run the pip install and we specified requirements.txt. So we've essentially run pip install, which is going to look and find all of these dependencies and then install them in preparation for us to then run this image as a container. So what we have now is our image fully set up for us to then create and run our Django application. Right, so now we're ready to test this out. Now I've left this underscore commands file here in the project, which you'll be able to access and view some of the commands that we use if you've forgotten them or just simply want to, like me, copy and paste them in. Right, so first of all, we need to run our Docker Compose file. So we use Docker Compose and then we use the up command. So the up refers to the fact that we want to actually take our images that we specified in our Docker Compose and Dockerfile. We want to download them and we then want to start them as images. And of course, Docker is going to use all the instructions that we've specified here to set up our images and then run our containers as specified. We use the build flag. So this is going to tell Docker that we want to actually download the images and run the build. So here we obviously need to download and perform some additional actions on one of the images before we start it. And then the D flag just means that we're going to run Docker in the background. Typically what happens when we don't use this D flag is that we will then return the container terminals here in this terminal so we can actually see the outputs of all the containers, and we don't necessarily want that. Because then we can't access the terminal further. So we use the D flag here. Everything's just going to be running in the containers. And as and when we want to, we can just interact with the container through Docker desktop. Right, so if you run that, that's probably going to take a little bit of time, depending on your internet speed. You're going to need to download the images, and they can be anywhere between 100 and say 300-400 meg. If you do have any problems or issues, don't forget you can download the source code connected to the module primer tutorial, the first tutorial of this module, and that will be the case throughout this course. Anytime you want to access the source code for any module, you will find it connected to the first tutorial in every module. Right, so everything does look good so far. If you take a look at Docker desktop at this point, you should have two images, and you can see we have this Postgres image and this Django GraphQL project image. You can see it's quite a large one here, 1.21 gig. And then we've got the container. Now notice this half moon, which is indicating the fact that there's a potential issue here. And you can see that this it is indicating the fact that it's trying to restart constantly. Now it looks like the database has started. So the database looks good and ready to go. It's ready to accept connections. That's good. But the Django app, you can see it's flapping. It's trying to potentially start, but it can't. Now that is expected at this point. The point is here is that this container will not start unless the service successfully starts. And of course, we haven't actually started the service yet. Thus, the container has not started. But what we do have is our baseline setup, which we can now build upon and create our new Django project in the next tutorial. What we have done here is we've written a basic Docker file and a Docker Compose file for our Django and Postgres container. We've defined these services in our Docker Compose file, of course, and now we've run and we've made sure that both containers start together, which they do. Of course, we now need to create our Django project so that we can start fully our Django container.